The goal of this lesson is to determine the relative position of two straight lines using their respective slope and y-intercepts. If two lines have the same slope only, then they will be parallel, so will never intersect. If two lines have the same slope and the same y-intercept, one will be superimposed over the other, which we call coinciding. They share every single point on their lines. If two lines have neither slope nor y-intercept the same, they will then intersect at one point in the Cartesian plane. Finally, if two lines have slopes that are negative reciprocals, for example 1/2 and -2, they are then perpendicular to each other. A quick way to check for this, when you multiply the two slopes, they will equal -1.
In this lesson, let's learn how we identify lines that are parallel, perpendicular, intersecting, or coinciding. And we'll do it by just looking at the equations. So we need to determine if these two lines are parallel, perpendicular, intersecting, or coinciding. How do we do that? We know the formula for a line's slope formula is y equals mx plus b. The slope-intercept way of writing the equation of a line. So let's look at both these lines. I'm going to draw a line here and actually do the calculations on both ends. Here, what do we know? What is m? The slope equals 2. Here, what do we know is the slope? mx. Slope equals 2. What is the y-intercept? Here is 3. Y-intercept here is -1. So we can see two lines have the same slope but different y-intercepts. If they have the same slope, they are parallel lines. And they are parallel and not coinciding because their y-intercepts are different. So another way of doing it would be, this would be one line, y-intercept, and this would be another line with a different y-intercept. If the slopes are the same and y-intercepts are different, right, then these two lines are parallel. So in this case, the lines are parallel, and we did that by looking at the slopes and the y-intercepts. Let's do another problem. In this case, we will look at these two lines. Okay? Now, this is y equals 3x minus 5. Slope equals 3, y equals mx, and b equals -5. Right? Let's find the slope and the y-intercept here. I'm going to solve this equation. So we will leave 2y here, and we will subtract 6x from both sides. So I subtracted 6x from here and 6x from here to get -2y equals 10 minus 6x. Now let's divide by -2. Right? What do I get? Y equals 10 over -2 is -5, and 6x over -2 is plus 3x. Right? Now if I look at the slope of this particular line, slope m equals 3, and the y-intercept b equals -5. Right? So we can see slopes are the same, y-intercepts are the same. If slope and y-intercepts are exactly the same, then the lines are coinciding lines. They are exactly the same lines. As you can see, the equation is the same. So these two are the exact same lines. Right? Let's try and solve the third one. What do I see? Y equals 5x plus 8, which means slope equals 5, y-intercept equals 8. In this scenario, y equals -1 over 5x minus 3, which means the slope is -1 over 5, and the y-intercept is -3. That's what we're given. As we can see, the slopes of the two lines are reciprocal, which means it is opposite. One is 5, the other one is -1 over 5, right? So since they are reciprocal, and 5 times -1 over 5 equals -1, so the multiplication of the two slopes gives us -1, that means the lines are perpendicular. For any two lines to be perpendicular, their slopes, when multiplied, have to result in -1. So if I multiply the two slopes, 5 and -1 over 5, the answer I get is -1. If the multiplication of both slopes is -1, then the lines are perpendicular.